Zero factor property. Once you have a polynomial completely factored and you have all the factors on one side and set equal to 0 on the other side, you can use the zero factor property to actually solve the equation and find out what values you can have for your variable. Since the factored polynomial is set equal to 0 and you've got things being multiplied, for example, sum A times sum B, set equal to 0, the only way you can get things to multiply to 0 is if one of the factors is 0 or the other factor is 0. And that's the basis of the zero factor property, because if we have a product of factors set to 0, one of the factors has to be 0. So we assume that, and then we'll just set each of the factors equal to 0 to see what is the value that would cause this factor to be 0. And then that gives us our solutions. So for example, we have this factored polynomial x minus 2 times the quantity x plus 9 set equal to 0. So what the zero factor property is telling us, say this is your A and this is your B, and they're being multiplied, it's saying, for example, that x minus 2 has to be 0 or x plus 9, the other factor, has to be 0. So basically we take each factor and set it to 0. Then we can solve, we have just little bitty equations here, solve for the variable, so I'll add 2 to both sides. That'll give me x equals a positive 2 for that one. And for this other little bitty equation, I'll subtract 9 from both sides, and then I end up with x equals a negative 9. So what we're saying is that either if I have an x of 2 or of negative 9, it's going to make a true statement in this equation that I started out with. So let's check that and see if it's really the case. So I want to check. And the first thing I want to check is if my x is a 2. So I'll plug it into the original equation just like I would check any other value and say 2 minus 2 for that first factor, 2 plus 9 for the second factor. I'm checking to see if it comes equal to 0. And when I subtract those first two, 2 minus 2 does give me a 0. 2 plus 9 or 11. And that's set to checking to see if it comes to 0. 0 times anything will give me a 0 on the left, and then I have a 0 on the right. That's a true statement. So what happened was when I used 2 for my x and plugged it in both places where I saw the x, I came out with a true statement. So that means 2 is one of my solutions. And then I will check the other solution I came up with, which was a negative 9. And I'll plug that into the original equation where the x's are. So I have negative 9 minus 2 times the quantity negative 9 plus 9. And I'm checking to see if that comes to 0. Well, I know that this isn't going to give me a 0, but this second factor is giving me a 0 for this one. So I'll have 0 times, and it doesn't really matter what, although this does come to a negative 11. But if I multiply anything by 0, I am going to get 0. So this one also checks out. So if I write my solution, I have x could be a positive 2 or a negative 9. We can write it in set notation, or we can just say x equals 2 or negative 9. Let's look at another example. This one, when we start off, I notice it's not in that nice factored form that the previous example was in. So the first thing that I've got to do is factor. So I'm looking first, I'm counting. I have 1, 2, 3 different terms. So I'm thinking I probably need to use some product. And before I do that, I want to check if there's a greatest common factor for the whole polynomial. And I see my lead coefficient is 1, which means that there won't be a number that's a greatest common factor. And then on my last term, there's no x, so I know there won't even be an x for a greatest common factor. So I just need to go straight to a sum product chart. So the sum, remember, comes from your middle term, and that'll be a negative 4. And the product is a product and it is the positive one that's implied here times the negative 32, so positive 1 times negative 32, which comes to a negative 32. And then I'm looking for factors of negative 32. So first I'll just start by thinking of the positive numbers that multiply to give me 32 because that'll help me out. If I'm stuck, remember I can always start at 1 times 32, and then think about the next number up from 1, 2. So 2 times, 2 will go in because it's even, so 2 times 16. Does 3 work? If I add 3 plus 2, I get 5, and 3 doesn't go into 5. What about 4? Yes, I know 4 times 8, so I'm going to write that down. And 5 won't work because the number doesn't end in a 5 or a 0. And 6, I'm thinking 6, no, because 3 didn't work. And if 2 and 3 both work, then 6 would, but if only one does, then 6 won't. And then 6, 7, that's not a multiple of 7. And 8 is the next one I can think of. It's already showing here on my list, so my list is complete. And now I just want to look for, if I want a negative sum, I'm thinking, what can I put, which way, if I put my negative here on the 1 and multiply by 32, I'll get a negative 32, but when I add, I'll get a positive number. So the negative needs to go on my larger number, and we'll put it right like that. And then now when I add these, this one's going to give me negative 31. That's not negative 4. This one will give me negative 14. That's not negative 4. And when I add these two, I get negative 4. There's my pair with the signs and everything. So I want to write this one out as x squared plus 4x minus 8x minus 32 equals 0. And I'm going to leave that equals 0 on just so I don't forget. I'm trying to solve, not just factor completely. And I also want to double check that when I add these two terms together, that I do get that negative 4x that was there in the original problem. And so I have a positive 4x plus negative 8x, and that will give me a negative 4x. So this is an equivalent representation of my problem. And then I just want to erase here. Okay, and then I have 4 terms now, so I'm going to use factor by grouping here. So the first 2 terms, what can I factor out? Well, there's a common x, and what's left, so x times what gives me x squared, so that's an x. And then x times what gives me positive 4x, so that'll be a positive 4. Then I can double check, x times x will give me x squared. X times positive 4 does give me 4x. And then look at my second set of factors, or terms here, I'm sorry, my second set of terms. I have negative 8x minus 32, and I'm looking for a common factor. It looks like it should be a negative because I see a negative on both terms. And then I should probably factor out an 8 because I know 8 goes into 32 as well. Nothing for the variables because this negative 32 doesn't have a variable. So then I'm asking negative 8 times what will give me negative 8x? Well, I'm going to need an x. And then negative 8 times what will give me negative 32? And I know it's 8 times 4 for 32. And so I'm thinking what sign? So I want negative times what will give me a negative, and it's times a positive, so that'll be a positive 4. And still setting it equal to 0. Not quite done yet with my factoring. I have one more greatest common factor. It's right here, this x plus 4. See how that's being multiplied by both terms? So I'm going to pull that out to the front, x plus 4. And I'll multiply that one by what's left over, x, and then a minus 8. Now set to 0. Now I'm to the place where I can use the 0 factor property. So we'll put that in right here. And so what I want to do is set each factor, x plus 4 equals 0 and x minus 8 equals 0. Because remember, I have 2 factors that are being multiplied together and the product is 0. The only way I can get a 0 for a product, things being multiplied, is if one of those two or both are a 0. So I'm going to just set each one to 0 and see what values of x would cause me to have a 0 for either of the two factors. So set the x plus 4 to 0, x minus 8 to 0, solve for the x. So if I subtract 4 here, then I have x equals negative 4. And then this one I need to add 8 because it's being subtracted right now. So add 8 to both sides. And I end up for this one, x equals a positive 8. So I have two solutions here. I want to check them. The first one I want to check is x is a negative 4. And I want to check from the very start, because if I start down here where I have it already factored, then all I'm checking is that from the factored point on is correct. But if I want to know if I have the correct solutions, I'll go back to the original problem and work it from there. So I have negative 4 in instead of the x, quantity squared minus 4 times negative 4, and then minus 32. This should come to, and we're checking, should come out to 0. So negative 4 squared, negative 4 squared. Remember that means negative 4 times negative 4, and that gives me a positive 16. So this first term is 16, and then I have negative 4 times negative 4 again, and that'll give me another positive 16, and then I'm subtracting 32, still checking, is that equal to 0? 16 plus 16 is 32. And then I'm subtracting 32, so I will get 0 from that. So the negative 4 works for my solution. Now I want to check the next one, which is x equals 8. So instead of the x, I put in an 8, and I'm squaring it. Minus 4 times 8 minus 32, is that equal to 0? 8 squared is 64. Negative 4 times 8 will be negative 32 minus 32, checking if it's equal to 0. And 32, negative 32 minus 32, that's just negative 64. And so I can see now positive 64 plus negative 64 definitely gives me 0. So both of those answers check.